Okay, hello everyone. How are you? Welcome to this talk where we're going to talk about SAP. We're going to talk about spyware, ransomware, worms, and how to prevent the next SAP tragedy. First of all, there is always the disclaimer that I always like to put, basically, is that I don't intend to override any of the privileges that SAP might have to the different products. No one reads it anyways, but it's always nice to have. Okay, so who am I? My name is Jordan Santarsieri. I am the founder of Vixer. I'm going to tell you later on what Vixer is. My background probably is just as yours. I started to be like a general penetration tester. You name it, like Apache, Core Switch, etc. And then I slowly specialized on the ERP world. That was several years ago. I am a speaker and training whenever I have the time at different security conferences like Black Hat, OWASP, Hacker Hat, you name it. And thank you very much. Now the 44Con. And I had the privileges to basically work with several different organizations around the world. You name it, like from the military space, ONGs, big organizations, etc. This is the brief agenda that I have for today. We're going to start with a really brief introduction to SAP. I'm aware that not everyone might know about SAP, so this chapter will be important so we can stay all at the same level and all of you can understand the attacks. And later on, we'll have the project RSAP. I'm going to tell you what it is and how it was born. A traditional approach to malware distribution, this is actually a real case that happened in SAP. And chapter 4, I'm going to show you what I have been researching so far, what is the status of the security of the SAP systems in the current market, and how someone can abuse of that, and from the other side, what we need to do in order to prevent it before it's too late. Okay? So, without further introduction, we start. So the main question for you might be, okay, what is SAP? You might be wondering. Okay, so SAP stands for an acronym of Systems, Applications, and Products in Data Processing. Basically, it's a software that is designed to satisfy all the different needs that a company might have. Logistics, HR, process of payments, credit cards, etc. Everything is centralized in SAP. Chances are that a part of the SCADAs, SAP is like the most important software that an organization might have. So let's go by the numbers. SAP was founded in 1972 by ex-IBM employees. I don't know if you know the story, but basically these guys were working on an ERP for IBM, and I don't know why, but the project gets cancelled. And these guys say, okay, wait a second. We do have something really good here between our hands. Why don't we just split up, create our own company? And that, let me tell you, my friends, that was one of the most successful business decisions in the history of modern software. These guys, I think they are like the 4 biggest independent software sellers of the world. They are gigantic. And look at those numbers. I mean, they have almost 90,000 employees worldwide. They have more than 378,000 customers. They are almost in every single on every single country that is out there. And I think the most important number is the one that you will see at the end. Look at this. The Forbes Global 2000, that represents the most powerful and richest companies out there in the world. And 87% of those companies are currently using SAP. These guys completely dominate the market. For this extremely brief introduction, we're going to separate the SAP solutions in 2. This is not what you will find on the documentation, but we just have a very limited time in order to speak about the different solutions. From one side, we will have the enterprise solutions, and from the other side, we will have the supporting solutions. The enterprise solutions are the most important ones. On simple terms, is where the money is. If the company only has one system, that will be the SAP ERP. That's the heart of the entire SAP landscape and organization. If the company is processing credit cards, it's going to be on the ERP. If they are processing payments, it's going to be on the ERP. Then you have the BI. BI is more focused on how we sell more and a more efficient way to our customers. CRM will centralize every single interaction of the customers with the company. You can start getting a sense that very powerful information is stored on SAP. From the other side, we just have the supporting solutions. It will not be the main focus of this talk. Basically, the supporting solutions will support the enterprise solutions. And at the difference of the enterprise solutions, where the people that actually log in, most of them are just regular employees, on the supporting solutions, you will expect more technical users or more administrator users. All the systems on the enterprise solutions are something that is called NETWEAVER based. So what is this NETWEAVER that I mentioned? Basically, it's the framework where SAP sits in. NETWEAVER is service-oriented and can be divided into ABAP and Java. ABAP was more designed to be like a back-end type of stack. Basically, ABAP is the specific part of the NETWEAVER systems that holds money. Credit cards, as I mentioned before. And Java was more designed to be sort of like a front-end system, and is slowly being deprecated. We do have systems that are pure ABAP, and we do have systems that are pure Java. And also, we have systems that are what is called dual stack, meaning that it will contain all the different services that ABAP has, and it will contain all the different services that Java has. From an attacker perspective, that is awesome. The broader is your platform, the more chances you have to compromise the system. Now, this will be like the welcome to the ERP war, and this is not something that is exclusively of SAP. Each one of those services that I was mentioning before, most of those services are proprietary. Meaning that the protocol is not open, and in most cases there is no technical documentation whatsoever on how the protocol works. The only way that you can do to actually figure it out how it works is through reverse engineering. Then there are even more crazy stuff. For example, some protocols don't even consider authentication. The authentication layer itself is not even embedded in the protocol. And this goes without saying, most of them are not encrypted by default. So how people actually log into the SAP systems? Well, you have many ways. The most common ones are the SAP GUI, which is a client, a very extra thick client. The installer is more than 1.4 gigabytes, for example. And then you have through the web application servers. ABAP has its own web application server, which is called ICM. Java has its own web application server, which is called Java HTTP. And then you have another thing that is called HANA XS or HANA XSA, that basically in terms of recycling of the technology is just ICM with steroids. Of course, every single one of those web application servers that I'm describing are proprietary. Again, we don't have technical documentation of how they really works internally. We have a few things, but the documentation is very limited in that sense. So why, if you haven't been paying attention, why someone would try to attack an SAP system? I think the most cumbersome definition is where the money is. Attackers know that SAP will have money. Attackers know that the organizations highly depend on SAP systems, so there will be very valuable information inside those systems, or maybe just don't like you. They are targeting you for something in particular. So, what is this Project RSAP and why I'm here? The structure of this talk is a little bit different now. Why I'm still introducing myself if we are already finished with chapter 2? Well, it will make sense in a few more seconds. As I told you before, I work for an organization that is Vixer that I helped founded, where we basically focus on Oracle and SAP. It's mainly ERPs, like pen tests, vulnerability assessments, tons of forensics, which I love to do, but each time I do, I lose 2 years of my life, and trainings, which I did here for the 44 Con. Why I'm telling you this? Well, we are a relatively young company. And as many young companies out there, we have the same challenge that everyone has. Okay, so how do we get new leads that will transform in customers? Most people will do the traditional approach. What they do is they just buy a list of companies that are already using SAP, for example, and they start doing some cold calling. This is, or the success rate that they get is 1%, and it's exactly the same success rate that spammers have, which is not a coincidence if you ask me. So we say ourselves, okay, we are hackers. I mean, we are supposed to find a better way to solve this issue, what we can do. And that's how the project RSAP was born. Basically, what we did out there is we took every single point of information, every source, every data source that we could get, like Shodan, Google, Bing. My personal favorite, if you haven't checked it out yet, I would recommend it, is Sumai. It's like Chinese version of Shodan. And basically, I was forgetting something important. Also, we took a few resources from the deep web. Some, of course, search engine in some very sketchy forums. We basically wanted to create a live map of SAP systems that were exposed to the internet. We had to create an extractor for each one of those data sources. Basically, it's a Python script that periodically will connect to those data sources and pull out the information. We will compare the new information with the systems that we already have. Why we did this? Because we knew from the very beginning is that that map will be live. You won't believe it, but there are many organizations out there that are part of publishing production, which is what you will expect, that also publishing QA and dev, which makes absolutely no sense. Apart from that, okay, we say, now we have a list, but we need to make sense of this raw data that we are working with. Fortunately for us, the web application servers in SAP are quite verbose. Look at those headers that we got. SAP NETWEAVER Application Server 721, Application Server Java 731. SAP NETWEAVER Application Server 722, Application Server 730. There is no doubt that you're dealing with an SAP system. And lucky for us, also, it provides us with the version. So we know that the systems that are out there, we know the version, we know exactly where they're being hosted, by country or by continent. And this is a clarification here. Even though we find that an SAP system is being hosted in one country, that doesn't necessarily mean that the owner of that SAP system is from that country. For example, AWS Singapore is hosting a massive amount of SAP systems, and they do it for the whole region. Now, and we found several interesting things. We found, for example, that very few, in percentage, very few of them were having a proper level of security. A lot of self-signed certificates, a lot of certificates that they were expired, many more things that I'm going to comment very soon. So what we did, we just compared the version that we had with the knowledge base or internal knowledge database in terms of vulnerabilities that we have. Some of them were published by all the researchers out there, and some of them, the private ones that we hold. These are potential results. What do I mean with potential results? We didn't actually trigger the attacks on the SAP systems. We just compare the versions. We know for sure that they're vulnerable, but we don't want to break the law and go and try the payloads. Are you intrigued by the results? Well, let me tell you before I show you the results that all these will be summarized on a paper that we're going to release by the end of the year, maybe before, but more or less by the end of the year, where it contains the pure data of there. Of course, I'm not going to give you the name of the companies that own the SAP systems, but at least you will get the big numbers, and we're planning to do it per region, so you will have something good. In total, we found more than 14,000 SAP systems directly exposed to the internet. And let me make a clarification here. Maybe you think about it and you say, okay, well, yeah, 14,000, but it's not that bad because I already have a WAF, or I already have a firewall, for example, or an IPS. Well, if you have a firewall, you have to let me pass through the port 80 or 443, and it's only what I need to compromise your SAP system. If you have a WAF, or if you have an IDS or an IPS, good luck for you, because most of those stuff do not have a single signature to catch SAP attacks. Maybe you will catch if the attacker is invoking the cmd.exe, because if they will parse the entire string, I will detect that that might be part of an attack. Maybe you will catch it if the attacker is trying to use bash. But if someone is using pure SAP stuff, forget it. This is funny. For all those 14,000 systems that we were able to get, we were able to identify who was the owner of almost 40% of them. SAP is like a Ferrari. It's extremely expensive, right? To buy the license, to implement the entire thing. There is no such thing as an orphan Ferrari. So someone has to own that SAP system. By using techniques, reading the metadata, reading the certificates, and so on, we were able to identify the owners of the SAP systems. And I think this is the most powerful number. For all those 14,000 SAP systems, we saw that 27% of those were exposed to critical vulnerabilities. And when I say critical vulnerabilities, I want to clarify. Remote command execution, file upload, file download, path traversals, you name it, it was there. Of course, again, we didn't try the payloads, but by just knowing the versions, you can figure it out. So we were highly surprised. Actually, I was not expecting the number to be higher than 5 or 7%, more or less. But it was far more than we were expecting. And we say, okay, wait a second. If someone right now is deciding to create something malicious, like a worm, etc., this could be a real tragedy. How you will say? Well, keep watching and I will give you a few hints. How to attack and how to defend, of course. We are the good guys. We're trying to help people. You got email. This is like a real scenario that has happened before. Of course, at this point, when I show you the demo, I have several demos for you, and I'm crazy enough to do it live. I have 2 SAP systems running on my machine, so let's cross the finger for the demo gods. I find myself having to downgrade, with the need of having to downgrade a little bit this attack, just because I don't want to give everything away of people doing a malware campaign on SAP. But if you have more questions, or if you have a hint of, hey, if I do X, Y, Z, I will be able to power up this attack later on, I will say yes or no. Okay, so think about it. We need to start thinking like an attacker. An attacker already has a collection of SAP systems. They already know what companies are using those SAP systems, and it's fairly trivial to do a small investigation to get emails, for example, of the people that work on those companies. The attacker knows that probably if they're using SAP, they're using SAP across the board. I mean, it's the whole definition of an ERP system. It's a solution that should provide help to the different parts of an organization. And the attacker also knows that if a company can have an SAP, most likely they have high resources. High resources means that they might have many employees. If they have many employees, they might infer that single sign-on is being configured inside the SAP system, which is the case of 97% of the organizations that are currently using SAP. So what happened here? Well, how we found this distribution of malware? Well, basically the malware was in form of something that is called SAP GUI scripts. It's basically a programming or scripting language that you can use for the SAP client. Basically, you will use this to perform batch jobs operations under the privileges of the SAP user that is actually executing those batch files. Here's the good part. By default, this functionality comes disabled, which is awesome. But there is a problem with that. This is the main way that companies have to actually do automatic testing in SAP, because it recreates the behavior of a human being. And because of that, 90% of the corporate users actually have this activated. I'm going to show you the demo, but first I wanted to show you the scenario. This will be the attacker that basically is going to distribute a typical SAP GUI script to the users, that the users will be in the VLAN, and then the operations will be carried out to this server's VLAN. The users, for sure, will have a firewall exclusion to go to the server's VLAN because it's how they need to connect to SAP in order to work the day-to-day operations. And I'm being quite generous here with this network diagram. Most companies nowadays, they don't even have a segregation between the users and the server side. Everyone tends to work with a flat network. So let me show you a little bit. Here I have one of the SAP systems for you. Just going to give you a brief overview. What this malicious script that I have created for you today is going to do is literally delete a table that will contain public debt. Basically, you can do whatever you want. This is just for the sake of the exercise. This is how you see a table in SAP. Basically, what the attacker wants to do, for example, is to clear out the amount of debt that each one of these persons have. Kudos for you if you can recognize some of the names. Okay, so what is going to happen here? Basically, the person is going to be working inside the SAP system and is going to receive an email. Here, and I make it on purpose, yet again, I created the SAP GUI script with the VBS extension. There are many tricks to bypass this and to make the SAP GUI script or the malware almost indetectable, but yet again, I don't want to be responsible for something bad. Basically, the person will do a double click on that file and automatically all the actions will be carried out inside the SAP system under the privileges of that person. Even if you go to the logs, you will see that the actions will be performed on the victim's name. And that's about it. If you're not paying attention, as you could see, the execution was actually quite fast. Remember, this is something automatic that people use to do the automatic testing. And now, if we go to the table, you will see that the values are modified. Again, this is one of the examples. Basically, you could do everything here as long as the user has enough privileges. Shut down the SAP system, get the credit cards and forward the credit cards to a netcat that is listening or to an HTTP server that is waiting for the credit cards and so on. The possibilities here are limitless. Unfortunately, most people cannot disable this functionality. They all needed to do this kind of testing. But if you cannot, there is one thing that you can do. Basically, on new SAP systems, you can say, okay, allow the scripting for all the users, but only allow the execution to be for the users that have a particular authorization option, a particular privileges called S_SCR on value 16. You will be raising the bar a lot because ideally you only want a very handful of users to be able to be used for automatic testing. The other ones have no reason to be here. And then you can also configure the client to notify you whenever a SAP GUI scripting is about to be executed. So you can say yes and no. Unfortunately, again, this on the market right now, people tend to disable this a lot. Okay, so now we're going to talk about the weaponization and the prevention. We're going to go more to what we have found that we could do on the systems that were exposed to the internet. The first thing that we talk about is like, okay, no, if someone creates a worm, that would be really, really bad. That would be a high and really real danger out there. We wanted to help, but before we could help, we need to understand how someone will create the malware to attack the SAP system. What we did is to start studying previous malwares, previous ransomwares and worms, and we discovered that some of them share some personality traits. For example, they were designed to hit hard. Lateral movement was goal because you want to compromise as many hosts as you can. Avoiding making noise was not a priority. You're hitting hard, you're moving fast, not necessarily you want to keep it quiet. And they're open to weaponize. What does it mean? It means that the attackers that really want to trigger this, they already have a framework for the ransomware or for the worm. The only thing that they need is the silver bullet that they're going to use to penetrate the systems and do the lateral movement. But the framework itself is already there. They're just waiting for the right opportunity. This will be the scenario that we have. And this scenario is very similar to what you will find on the systems that are exposed to the internet. The attackers or the people that want to interact with the SAP system are going to connect with a SAP system, in this case a Java one, that is on the DMC. Most likely that Java system will be connecting to a system, a backend system, ABAP on the DMC. I'm being very generous here once again. In general, people have everything on the internal network. And finally, and this is because how SAP works, SAP has been born to be highly interconnected, that backend system will indeed need to speak with the systems on the internal network. What does it mean? It means that that particular box will have access through the firewall. The attackers know this. So what we're going to do here, we're going to divide the attack on 5 different phases. The first one will be the intrusion one. Why? Because you need something to compromise the first Java system that is on the DMC. Once you compromise that SAP system, you need to start gathering credentials. You want to do lateral movement. Once you get the lateral movement, that could be with many things like reutilizing the password guessing, brute force, etc. We're going to do something else. Once you do that, then you escape the DMC because you want to hit the LAN. For that, at least for this demo, I'm going to show you how an attacker can take advantage of something in SAP that is called master password, and how they can use the different interfaces that SAP provide to actually attack in those systems that are on the user's network. And finally, coming back to this model, we are not just good enough with attacking the SAP servers that you see on the internal network. We also want to attack the people that are connecting to those servers. We're going to see how we're going to do this. Each stage, I'm going to show you like a demo, and I'm going to show you some of the codes. Of course, the main malware or the main simulation of the malware is not going to be distributed for obvious reasons. I mean, my end goal here is to help people to prevent this, not to help people to cause this. But yes, I will show you some code, and if you need later on, you want to see it in detail, you can ask me, and I will be more than happy to show you. Okay, as I told you before, the framework of compromise is already there. What we need is the silver bullet to actually get inside the front-end system that is on the SAP system. Unfortunately, right now, you have like 3 remote common executions that are pre-out, that are somewhat known to the public researchers. On purpose, I'm going to select the oldest one, again, because I don't want to hide someone to create the worm, but know that there are 3 different alternatives to what you're going to see this. And unfortunately, even if we take the oldest exploit that I'm going to show you, according to our investigations on this project RSAP, 3 out of 10 SAP systems that are exposed to the internet right now are still vulnerable. So let me show you. This is one of the SAP systems that I brought for you today. It's a Java one. And let me show you how complex the exploitation is. Basically, there is one particular URL that you see right there, and I'm going to show you later on the code, that will gladly take operating system commands directly from you. For example, here you see that those commands are being executed under the context of the user that is running the SAP system. Here you can shut it off, corrupt the kernel, jump to the database, because the SAP system always maintains a trust relationship with the database, so you will be able to execute queries without even providing a username and password for the database. Let me show you right here. This is the code that I have prepared for you. a little bit unnecessary, at least for this part, because as I saw you before, it's literally just a URL. But I just wanted to show you that you can execute pretty much whatever you want as long as a valid command. Okay, so the first part for the attacker is quite simple. This exploit just gives you the ability to completely pound the system that is in front of you. Here, this scenario is already really dangerous. The worst thing that can happen to us is someone to set foot on our DMZ. Once they gain terrain, it's just a matter of time for an attacker to start spreading and trying to jump to the internal user's network. First of all, why this application exists, you might be wondering, and why it exists without authentication? Well, this is something that is called the invoker servlet that invokes something that is called config servlet, that basically is an application that SAP uses to install itself. I show you a execution of operating system commands, but that handy application also allows us to create users and assign whatever privileges we want to those users. For example, you can create yourself an administrator with just 2 post requests. So what do we do with this guy? Well, you have to apply 3 different SAP nodes, and nodes is like a patch that you have on the SAP world in order to actually mitigate this vulnerability. Unfortunately, many vulnerabilities in ABAP are just default misconfigurations, but in Java, the only thing that you can be ahead of the curve is if you patch. There is no other way. Just an FYI, in case you need to apply the 3 nodes, if you're missing the 3 nodes, please read the node 1467771, because there is a bug in one of the fixes that you have for the SAP systems, and if you don't apply that node, you might lock out your real users from the SAP system. So there is a patch for the patch, just an FYI. And unfortunately, like many things in SAP, as the cores have been evolving from the 80s, they are very monolithic. For many of the operations that you will have to do, you will have to restart the SAP system for the changes to take effect. You will be able to easily do it on dev, you may be able to easily do it on QA, but in production, for most of the companies, that is a challenge. They usually have a window of opportunity where they can actually do the restart. So, okay, yeah, we were able to compromise the first system, if you remember the diagram. Now we need credentials. Why? Because we want to start doing some lateral movement. For lateral movement, I wanted to keep everything like on the SAP sphere. What you could do is to just try Mimikatz, or just try to put Metasploit there, or put a nation of Metasploit and start targeting the OS on the database. But for the sake of this talk, we want to keep it SAP. There is something on the Java systems that I already showed you before that is called the SAP Java Secure Storage. Each stack has its own storage, but we are on a Java system, so we're going to talk about this guy. Basically, it's an encrypted file that sits on the file system that is encrypted with triple des. In order to decrypt that, you will have to have a passphrase that the user specifies at the installation time and a key. Unfortunately, that key is hard-coded on the binaries. So if you know the key, and if you are able to get the files, you are able to open this secure storage. And guess what's inside? First is the password of the SAP administrator, and second is the entire JDBC chain for the SAP to be able to connect to the database. For those of you that you are not very familiar with Java programming, if you had the full JDBC chain, it means that you also had the password for the user that is going to be used at the database level. Decrypting this, is really trivial. As I told you before, the only thing that you need to have is the key. This key that is hard-coded in the application. So what I did there is basically I took the SAP application, I played with it a little bit, actually I customized it just a little bit, and I created my own decryptor of the secure storage. Basically, once the decryption is done, it will gladly give you the password of the administrator and the entire JDBC connection chain. That system is automatically found right there. So now we have the passwords of the administrators, we have the password for the database, we have everything. How we can protect this from happening before we continue with the lateral movement? Well, first of all, the secret storage must be protected. Those are the files that actually you need to be protecting. Basically, you need to be sure that only the SAP administrator has access to those files. And the passwords that you see there must be different from the master password. We're going to see very soon what a master password is, which is one of the main issues that modern implementations of the SAP systems in the market are suffering right now. So we already have the front end. Let's go for the back end and let's try to jump in. What we're going to do here is to try to compromise the other ABAP system, right? We have the credentials and we might try to reutilize them, but let me tell you something, it's not necessary. Why? Because the way that the Java systems speak with the backend SAP ABAP system is through something that is called JCO. Basically, JCO is a wrapper that they have to speak the main protocol of communication that SAP has that is called RFC. It's just a plain wrapper. The JCO will come with what is called a JCO destination. What is that? Basically, at some point of your database, you have a hard-coded connection with the hostname, the port, the client, that we don't care what it is right now, a username, and a password. Of course, that information is encrypted. But how do you think it might be encrypted? You guess it is exactly the triple S and is with the exact same key that you saw before. This is a problem that I find very often. It's like people trying to reutilize not just technology, if not crypto, and even hard-coded credentials. It works like a charm when you're a researcher. It's a big headache when you are on the blue team. So we also automatically, that will give you direct access to the ABAP system also in the DMC. We have completely compromised the DMC with just SAP methods. Again, we didn't even need to do Mimikatz, we didn't need to do Metasploit, nothing. Just with the functionality that SAP gives us. And finally, as we want to jump to the user zone, we want to utilize the master password. Before I show you a really silly demo, what I did is to reutilize the master password. Basically, I want to define what is this master password. Basically, when you are installing an SAP system, SAP is going to ask you, hey, do you want to create a unique password for each one of the special users? The special users are Substar and Data Dictionary. Those are for the SAP application itself. The special users are the operating system users that SAP is going to create for us. The special users are the database, the SAP database users that we will have at the database. SAP is going to ask, hey, do you want to create a unique password for each one of those accounts, or do you want to use a master password? Basically, what the master password is going to use is reutilize that same credential, that one credential across everything. Every single thing. And unfortunately, the utilization of master password is what it comes by default. So guess how it is configured in most of the organizations? Yes, you got it right. In general, if you crack one hash of any of those guys, as I told you before, that system is completely compromised. Because how SAP works, in general, that same password that you find in one system, for example, let's say dev, is almost sure and almost guaranteed that that same password will be in production. It always happens the same, and is, as you can see there, 95 of the pen tests that we have used are using the master password for everything. So if you have one password, you have everything. And then, for example, you can use SSH to log into the systems, because you already know that the OS user that is being used by SAP will have that master password. Or you could use some other techniques, for example, that I'm going to show you really soon. This is just a really silly example of how you utilize the master password. You choose connect through SSH, you execute whatever you want, and that's it. It's not very special. In terms of interest of time, I'm going to just skip it because I want you to see the real deal later on. But if you have questions, you can ask me. Once we have the master password, once we have all the credentials, basically it's game over, right? Just by doing that very, very small sequence of steps that, by the way, I'm going to show you at the end, a program that does the whole thing, like command execution, gets the security store, decrypts the security store, and starts spreading those credentials pretty much everywhere. Once you get those level of privileges, that's it. Is game over. Is when you see this type of a screen demanding money or just complicating your life, ruining your vacations, or wasting your weekends. So why this is happening? Apart that the technology is being reutilized and the encryption and the keys are being reutilized. Why this is happening? What you can do from your point of view to actually try to apply some countermeasures to this. Well, basically there is something that is called RFC destinations that are very similar to the JCO. First of all, you need to have the less privileged approach, right? The user that you are going to put in any of the connections like JCO or RFC destinations had to have the less amount of privileges possible. And second, and this is key, you don't need to use the master password. Now on the latest and greatest installer, you don't have the master password, but as soon as you type the very first password, that password is spread automatically to the other users. Unless you go there and change it, it's exactly the same as having the master password. And finally, you need to revise your firewall strategy. I mean, you need to ask yourself, do I need such amount of SAP systems directly exposed to the internet? Can I do it better? Can I make the users connect through a VPN? So we are here, we're in the internal network because we are pretty much spreading the credentials to whatever we can use to log in. We want to tag, as a bonus, we want to tag the customers, the people that are actually connecting to the internal network. What we're going to do, basically there is a mechanism that SAP has that is called SOAP RFC. It's just a web application sitting on the web application server that will translate HTTP to this RFC protocol that I'm mentioning before. It has many utilities. This translation, you will have to invoke what is called a remote function call, like a piece of SAP software coded in a proprietary programming language called ABAP, that might do different things. The one that I found is one that sends an alert, a pop-up, to every single person that is connected to the SAP system. So basically, this hypothetical malware, what it's going to do is by spraying the credentials across all the SAP systems on the internal network, if the credentials are accepted, all the users that are connected at that time will receive a pop-up that says, hey, your SAP GUI version is deprecated. You need to download this small patch so you avoid disrupting the SAP system that you are connecting to. And of course, that small patch will be a URL that we control that will be on charge to spread the malware. Let me quickly show you. This is the payload that I have prepared for you. Here, I'm limiting the execution of this pop-up to just one user, but of course, the attackers will try to do this across pretty much every single user out there. The code is completely very simple because literally we are just hitting a URL. We are just hitting /SAP/VC/SOAP/RFC, and we are sending a post request with this XML that you see there. And let me show you what happens. I'm going to go as I was a regular user. I'm on my main screen doing my business. And after the attacker gets the spray, I will get a pop-up directly from the SAP client saying, hey, you're running a deprecated version, you must download my patch now. And that's it. You just don't have the server. You also try to make the users fall. You can put like backdoors. You can put like ransomware. You can try to force them to do any action that you want. Again, this was just one particular message. You could try to do many more things with different RFC function calls, but again, I find myself downgrading a little bit the attack because the objective here is to create conscience to people so they patch and do the proper SAP security hygiene instead of like allowing people to actually create a fully functional malware. So wrapping up, what did we learn today? A few takeaways. First, you need to ask again the question like, do I need all these SAP systems directly exposed to the internet? Are there alternative methods that could help me to raise the bar? Definitely there is no excuse to publish dev and QA. There is no excuse whatsoever. If a few set of developers want to work on your SAP system, just use VPN or use any other thing. There is no excuse to just publish the SAP systems there. Actually, one of the cases that I was a forensic investigator for a government, it happened exactly at that. As they exposed the dev and QA, people compromise those boxes and they start jumping around. There is something that SAP will include for free that is called the SAP Web Dispatcher, where it's going to help you to restrict the amount of web pages that you are going to make available to your end customers. For example, if you are only exposing a custom application that you have on that Java system on the DMC, you can only allow the public access to those set of applications, and that's it. You can deny the connections to every single other application that is out there. And I know that it's a very controversial topic, but patching is key. For everything that is SAP system-wise, patching is key. In general, patching in SAP is not that easy. I mean, it's not like patching a Windows server. It's not that you download a node, next, and that's it. You need to download the node, and then you need to follow what is called a correction instructions. Basically, it's a manual set of steps that you need to take. Most of the times, in order to actually finish the application of that patch, you need to restart the SAP system for the changes to take effect. Audit trails. Audit trails are extremely important. We didn't cover this on this talk because of time, but most of the audit trails, at least on ABAP, they don't come enabled by default. So in case of a security incident, if you don't have them, there is very little that a forensic investigator can do in order to analyze the attacks. Audit trails are key. For the Java side, the ones that we care about, lucky for us, or not lucky for us, this was a good move on SAP, they do come enabled by default. Then you need to make your SOC SAP aware. I always make the joke that IT security and the SAP team is kind of like a Venn diagram that never intercepts. From one side, you have the IT security guys that they know a lot about IT security, but they might not know a lot about SAP. And from the other side, you have the SAP administrators, which know a lot about SAP, but not necessarily know a lot about information security. And finally, prevent. Don't put yourself on the case of having to do a forensic investigation because it's a headache. You know when you start, you never know when you leave. And a part of that, because SAP is so huge, it has so many data sources, and if they're available, you have such a gigantic volume of logs, you can never guarantee that the SAP system has not been hacked. If you say that, you will be lying to your customer or to your employer. You can say, hey, I found evidence of compromise. Yes, your system was hacked, but you can never guarantee that the system was not hacked. Okay, so I think we have time to spare. If you guys have final questions, this is the time. If they are more sensitive, you can send me a private message here, or you can contact me at the conference. I will be here for the rest of the day. So don't be shy and ask away. If not, let's go to have lunch. Thank you for your time, guys.
Hi. Yeah, that's very interesting.
Sorry, where?
I'm here.
Oh, hey.
Yeah. So, I work as an incident responder. I'm really very interested in what you've discussed. Say I want to look into logs that will detect all those changes, all those things that you've been doing. What are the logs that I will focus on? Because I can't possibly look at everything.
That's an amazing question, and unfortunately there is no much documentation of that. When I had to start doing forensics, I found myself on that same issue. There was no documentation whatsoever, and let me tell you that it's not easy at all. First of all, and this is what I do on my regular forensics, is once I have all the logs activated, I need to create a parser per each one of those logs. Why? Because they are not homogeneous. Each log that comes from all the different services that you need to analyze, they're completely different from one another. Some of them are plain text, some of them are even binary. Once you create the parser, once you get the information, I put it on Splunk. Why? Because there is a lot of info that you need to start analyzing. And finally, and this is the most complex part, and this is the real bottleneck, you need to know about SAP in order to apply the heuristics, because you need to know what you're looking for. And unfortunately for that, unless you are an attacker, unless you have past time actually reverse engineer on playing with the core of SAP, there are no documents that will let you know exactly what to look for. That there is a gap that we as security researchers still own to the general public.
Cool. We got another one. I have two, so I'm going to ask my first one as I walk over here. Very quickly, in terms of comparisons of difficulty patching, have you compared SAP's patching process with the complexity of Oracle's patching process? And if so, which one was worse?
Well, I don't know which one is worse, but yes, in terms of complexity, absolutely. It's not as easy as a new patch is coming, let's apply it, guys. You will find, and this is very common, you will find a lot of resistance from the business. Something very particular that happens here is that if you want to patch a switch core, well, IT security owns that. If you want to patch a web server that everyone uses, well, IT security owns that. If you want to patch SAP, most of the times, the business owns that box. So you have to negotiate with the business when you have a window of opportunity, because you most likely will have to restart the SAP system for the changes to take effect. Yes, I will say that SAP is leader for a reason though, but yes, it's definitely not trivial.
I have another question. You haven't covered any real malware you can find in the wild. Is it because there is actually none? And all things you were describing are theoretical?
No, these are like very, very real. Actually, what I show you, it was the easiest way. It was the path of less resistance, which is exactly what an attacker will try to do. Later on, you have far, far more complicated techniques that if you know what you're doing, you can achieve, like attacking pure SAP components. But most of the stuff that you saw here are web-related, that everyone understands web.
My second question is, in doing this research and reaching out to companies, have you interacted with any of the audit firms, groups, people who look at auditing these things and looked at their attempts at securing these?
Yes, it's a funny question that you ask. You know that every time that you hear one of those buzzwords like blockchain or cyber, you start to feel the chill. But it's the only way that we have to differentiate ourselves with the regular approach that those guys will take. Those guys, when they say, I want to do SAP security, basically what they're doing is segregation of duties. Making sure that if I have a user that can create a purchase order, that user cannot approve it. But in terms of cybersecurity, as part of checking a few default users, that's about it. That's the value that you're getting. Don't get me wrong. You still definitely need segregation of duties, and a lot, because that prevents fraud. But someone needs to take or start thinking on buffer overflows, stack overflows, remote command executions, and those topics are not being covered nowadays by those guys.
That's a Afraid you'd say that. I used to know a J.D. Edwards auditor, and that's all we looked at. Questions before we close up? Excellent. Thank you very much.
Thank you, guys.